there. Sorry, recording watchers. Yeah, today is about conditionals in Python. So we're going to learn how to make these blocks. And yeah, let's learn how to make pointy things in Python. We need to learn to make things that can become true or false. We haven't talked about true or false yet in Python. So the bool type is where that lives. So bool is short for Boolean values, named after George Boole. So the bool type is a very simple type. You have your ints, your floats, and all that. The bool type only has two things in it, true and false. Those are the only values of the bool type. Whereas other types, right, you remember like ints and floats and things. Ints held infinite many things, just whole numbers, 0, -42, all those things. But the bool type only has two things in its cloud, true and false, with a capital T and F, by the way, if you're coming from another language. It's got to be capitalized in Python. So let me show you some of that at least. If I open up idle. Let's see here. There it goes. And then let me go to my notes as well. Yeah. So just on the REPL at least, like true and false exist. Be like, true. Yeah, the answer is true. What's the type of true? That is a bool. Haha. So let's do that in just a file so that I can show this to you later. Let me figure out what lecture, and this is lecture 17. So I'm going to save this in a lecture 17 folder so you can have it later. And I'll call it, I don't know, bools.py. And so I can print the type of the true statement. And its type is bool. Save, sure. Class bool. Yay. That all works out. Let me make these narrower so you can see both. All right. So that's what the bool type is all about. You can put bools in places. You can, of course, make variables that hold a bool value. You could be like, hey, b equals true. Save it for later. That's fine. And then you can print out b and use it in bigger places. But the whole point of the bool type is that you can use these trues and falses to control how your program runs. Right? It's all about, I can do one thing or another thing. I can do whatever I'd like. So here's kind of the setup. Like I can say, I want to do something like this. Like if I get a number from the user and I want to do something, do one thing or another with this number that I got. So like I want to check, hey, is n greater than 7, for example, something like that. And if the answer is yes, then I would like to do one thing. Otherwise, I'll do something else. And remember that yes in Python is going to be true. That's what truth means. And that's actually a comparison that you can make. So I'll go back to the REPL. It's like, hey, is 42 smaller than 43? Answer's true. It gives back a bool. You see that? So that's the power of comparing things. So that's kind of how I want to work. That's the goal, right? So you can ask these things in Python, like, is this variable greater than 7? Or by that I mean less than 7 if it's 5. So that's a true statement, and you can ask Python about that. You could also ask, hey, is m less than 3? And obviously 5 is not less than 3, so the answer is going to be no. Python will figure that out and say false to you. That is the idea. So there's that idea. Let me just make our n. N equals, what was it, 5? Is n less than 7? Sure. Is n less than 3? No. True and false. So these values will let us control our statements in just a second. Okay. Let's see what else. So the goal is to be able to make a program that looks like this. Like comes into a comparison. Hey, is n less than 7? If the answer is true, do one thing. Otherwise, if it's false, do something else. That's our plan. And yeah, you can put booleans in variables like b equals true. That's just the same as making a box that holds a number. It makes a box that holds a bool. Isn't that neat? So yeah, Bool values will be the ones that let us branch, because that's the true and false in Python. Okay, any questions about any of that? It's stuff you know from scratch, just presented differently, I guess. Okay, so yeah, let's talk about Boolean expressions. I think, yeah, that's where I want to go. So we want to make trues and falses somehow, okay? A Boolean expression is a piece of Python code that creates a true or a false for us. And so, like, for example, one way to make a true is to make two variables, x and y, in a very roundabout way, and then ask Python, hey, is x greater than y? Yes, it is, so it'll give back true. Let me show that to you on the REPL. So these kinds of things depend on other variables. That's okay. It'll get their values and figure things out. Make x 10, make y 5, ask Python, hey, is x greater than y? True. And that will let us branch eventually. But a lot of time we want to like check multiple things. So you have, of course, greater than, less than. You can't really type this character very easily in Python, or less than or equal to, so they just write it like this, a less than and then an equal to sign. Greater than and then a greater than an equal to sign. So for example, hey, is 2 less than or equal to 2? True. Is 3 greater than or equal to 1? True. That's how you write those. If you want to check for equality, it's double equals. Because you know you already use a single equals for assignment to make a variable have a value. So that one's overloaded. You can't use that anymore. But if you want to check if something is equal to something else, you use 2 equals. That's how they solved that problem. So double equals checks for equality. And then exclamation point equals checks for disequality. So like, is this not equal to something? That's, again, because it's hard to type that character on a computer. So let me show you some of those. Is 1 equal to 3? No. Is 1 equal to 1? True. Is 1 not equal to 3? Yeah, that's a correct statement. Is 1 not equal to 1? False, because it is equal. See that? That kind of makes sense. Let's see, what else do I want to show you? And then you can make bigger conditionals out of smaller ones, bigger Boolean expressions out of smaller ones. You can use and, or, and not, and you just type them. You just type the words and, or, and not. So, like, hey, true anded with false is false. False ORed with true is true. Not false is true. Stuff like that. So all the stuff that we know, just type it out, those Boolean expressions. Let me write that somewhere so we can have it later. So like print the result that is not, or not true. How about not B? Print not B, and if B is true, not B is false, right? Remember our conditionals? So that works like that, and then remember equality. That's probably the most important ones to know about. Print, hey, is 3 equal to 3? Double equals to check. Is 3 not equal to 3? So that will say yes and no, so true and false. Okay, any questions about any of that syntax? It might look a bit weird, but you have seen this all before. And yeah, the goal of and, or, and not is just to be able to combine things. So it's like, hey, is, I don't know, like pretending we're going to go on and make a program to see if somebody can go on an amusement park ride or something. Like check, hey, is the age of the rider greater than 12 and is their height greater than 48 inches or something. Okay, so the and gets to combine those ideas. Like this would be true by itself or false by itself. This could be true or false. And then the and make sure that they're both true so that the person can ride the ride. Yeah? So that is, remember your and, just a bit of a review as well. So remember that true anded with true is the only way to make true. The rest, true, false, false, true, false, false. If you and anything and one side is false, the whole thing is false because and's trying to check, hey, are they both true? Hey, are they both true? Okay? So, yeah, I think if nothing else, just remember the double equals to check for equality. That's the one that gives you back a bool. The equals by itself sets a value. And if you mix those up, really weird things are going to happen. Okay? So just watch out for that. And I think that is all that I wanted to say. Those are your comparisons. You got to type them out in Python. Plenty of examples that I hope help. Let's see here. Yeah, with that in mind, I think I have a question for you. So I've just shown you a bunch of conditionals and things. So, all right, let's pretend we have a variable called x, and we got it from the user. So like, there's no telling what it is. Like, you could print it out if you wanted to. But here's what I'd like to do. I would like to figure out, is x within the blue numbers? Is x one of the blue numbers? Okay. So here are some options. Which of these comparisons? There are some ands and ors, of course. Got to remember what those mean. Which of these comparisons is going to give back true when x is one of the blue numbers and one of the blue numbers only, and false otherwise? Do you understand the question? So it gives back true if x is one of the blue numbers. Could be any of them, and false otherwise. So give that a try. Please enter in your answers on the ByClicker page. I'll give you a few minutes to debate. Please help each other and convince your neighbors that you are correct. So how would you come up with an expression that is only true if x is a blue number, false otherwise? Maybe I should say capital true and capital false. All right, take one more minute. Get your best answer in. All right, so yeah, let's see what we're thinking. Please get your answers in. I'll give you a few more seconds. But I like this question a lot because you might have learned exactly what needed to happen as you did the question. All right, so we're thinking D, and yes, D is the answer. So good job, and let's talk about why. So A cannot be the answer because what is true when A is true? It's like x is greater than or equal to 4, so it's like the number must be in this direction onwards. And it also must be less than or equal to 15, so like it must be in this direction onwards. So it's okay, it will be true if x is 9, 10, 11, and 12, and that's not what we want, right? So it makes sense why A is not the answer, I hope, yes? That's extracting this range. That's pretending this whole range is acceptable. It'll give back true for any number in that range. That's not what we wanted. All right, what about B? X is greater than 4 and strictly less than 8. So greater than 4, so it can't be 4, so it's doing that. And it's less than 8, so it's doing that. So we lost 4 and 8 now because it's strict less greater than, strict less than. That's no fun. Or maybe the or saves us. I don't know. or it could be greater than 13, strictly greater, and strictly smaller than 15. So it's picking out 5, 6, 7, and 14. Do we see that? That's why B won't work. And then C, all right, x is greater than or equal to 4. Cool. So it's from 4 onwards. And it's smaller than 8. So it's strictly smaller. It skips the 8. That's definitely false because of that. And then or, maybe that or saves us again. It's greater than 12. So that's from 13 onwards because it's strictly greater. And it's smaller than 16. So that one worked for that. We just skipped the 8. That's close, but not quite right. So that's why it's not C. And then the last one will work. Strictly greater than 3, so from 4 onwards. And less than or equal to 8, so 8 and less. So that picks out that part. And then the or gives us another chunk to talk about. It's, all right, greater than or equal to 13, so from here onwards. But it also needs to be smaller, strictly smaller than 16, so from here down. Okay, do we see why D is going to be the right answer and pick out the range that we want? Any questions about that? That's a very common thing to want to do, like this range, or this range, or this range. And this is the pattern. It's going to be a bunch of ands to pick out smaller ranges, and then you or them together. All right, so that's that one. Let's see what next. All right, I'm ready to talk to you about the equivalent of if-else blocks in Python. They will be called if statements. All right, so an if statement in Python checks a condition, and it does something if it's true. All right, so here is what it looks like. You say if, and then you write your condition. If you're coming from another language, you do not need to put parentheses here. You say if, whatever your Boolean condition is, I'll call it cond, if x is greater than 42 or something. And then you put a colon, and then you press enter and you tab over, or you just put a bunch of spaces. I'll just say tab. Idle should do this for you. But you start typing indented code for everything that you want to happen when the condition is true. So the indentation is important. All right, so this is as many lines as you need, but they're all indented. Code to execute when cond is true. Right? Put as many lines as you need. They'll all get run if the condition is true. Right? And then once you're done with the body of this if, like you want to go back and just have normal code again that runs all the time, you unindent, or dedent, whatever it's called, and then you put the regular code that you have down here. Regular code outside of the if. That, as usual, always gets run. Always executed. Okay? So yeah, after the indented block is done, you unindent, and it just continues with the rest. So either, if the condition is true, it's going to run this code in the body, and then do the rest of the stuff. Or, if the condition is false, it's going to skip out on the body, and then just go straight here and run the rest of the unindented code. So that's what if statements can do. So let me show that to you. I'll make a new file called, I guess, conditionals.py. Conditionals.py. And here, I'll make a variable called x, set it to 7, and then I'll say something like this. If x is, I don't know, let's see, if x is greater than 5, something like this, print x is greater than 5. All right? That's the idea. Otherwise, if it's not true, we'll be like, or let's set x to 42 from the start. I think that will be the easiest example. So I'll change the x. If x is greater than 5, we'll print, hey, x is greater than 5, and then do stuff. And then we'll print this line always gets executed, no matter what. All right? And then, like, print other things. Like, this is just normal code down here. All right? But this is an if. This is the body of an if. It was indented. It will run if this condition is true. All right? And right now it is true. Yay. So it's going to say, well, x is greater than 5. Yes, that's true. So let me get rid of this one. It will print, yeah, x is greater than 5. It will run the body because this condition is true. And then it's done with the body of the if, and so it will just continue and run the rest of the lines. Okay? Any questions about any of that? And you can change all these things, like if x is greater than 43, I guess you have to print it's greater than 43 now. And that's not true, right? 42 is not greater than 43. And so it's going to skip out on the body. You see how it's going to run it only if the condition is true? And it just skips it and goes straight to the rest of the unindented code. Any questions about that? That's the secret. All right. So, I don't know. Let's just make this 10 or something normal. And so this is going to work again. And you can have as many lines as you want in the body. You know, as many lines as you want in the body. It'd be like x equals x plus 1. Only will these lines run if the condition is true. All of this stuff is the body of the if. All the indented stuff. So now it's like x is greater than 10 because it is. 42 is greater than 10. Make it 43. Print the 43 now. And then the rest of the code always happens, of course. But if I make this a smaller number now, like 7, the condition is false. And so it will skip out on all of that. Like none of this gets run because the condition is false, and it will just jump to the rest of the unindented code that always runs as usual. Okay? So that's an if statement by itself. It either runs its body or it doesn't, depending on whether the condition at the top is true. Okay with that? Because that's just a single if statement. You can also have something run if it's false. So there's an else part that we can add. Let's go and talk about that. There's, let's see. It looks like this. You can say if, maybe, let's just do it on the next slide. It's called an if-else statement. And, yeah, because sometimes we want to do something if it's true and another thing if it's false. The if-else is all about that. It's like check your condition. If it's true, do one thing. Do the true stuff. If it's false, do a different thing. Do the false stuff. There it goes. And then, of course, once they're both done, it'll come back and do your unindented code as usual. All right, so here is the syntax for an if-else in Python. You say if, you put your condition, as usual, like we just did, colon, and then you indent and you put all the true stuff, as many lines as you need. And then you unindent and you say else colon, and then you indent again and put as many lines as you need for the false stuff. That's the syntax. So if the condition is true, it runs all the true stuff. Otherwise, it skips that and goes straight to the false stuff. But it's either one or the other. Either this body gets run or this body gets run. Okay? So if the condition is true, the true case's body gets run. Otherwise, the false case's body gets run. And then it just jumps down to the rest of the code. All right? So that is that one. So let me show you that. Whee! So I'll section off this program. New stuff now. So let's make a y variable instead of an x one now. Let's work with y. Let's say y is 42. And then here's my new if-else statement. I'll say if y is greater than 10. Then I'll print y is greater than 10. Something silly like that. But now I can say else. Because if that's not true, it'll go here. Print y is not greater than 10, I guess. All right. And then once you're done with both bodies, you unindent, and you have just the rest of your code down here. Always executed again. All right. So I run this. Well, y is 42. That is greater than 10, so it's going to run this body and skip the else. It's always one or the other. And so it says y is greater than 10, and then it's done with the whole thing at that point, and it runs the rest of the code down here. Always executed again. Is that good? And of course, if I change y to be smaller than 10, it's going to hit the else, because it's going to see, like, all right, y greater than 10, is 9 greater than 10? False. So it's not going to run the true branch. It'll run the false case. All right? It'll say y is not greater than 10. And then it's done with the whole thing. After it's picked one side, it's done with the whole thing at that point, and it can run the rest of the code down here. All right? So that's why we see this output. Any questions about that? So that's the if by itself, and then also an if-else. I can run Something else if the opposite is true. If the original condition is false. Let's see here. All right, so let's go further. There's more. You can put things in between. You might have multiple conditions one day that you need, and you can use an if, else for that. So, for example, let's see. I think I just want to first show you the problem. You don't need this thing called elif that I'm about to teach you, but it makes your life so much easier. All right. So my best example of this issue, the reason you need this new thing called elif, is let's make like a grade calculation program. Let's get a grade from the user as a number, and then we'll be like just the standard grade calculation. Let's check if it's like greater than or equal to 90. If so, we'll say, yeah, your grade is an A. Let's pretend there's only A, C's, and F's just to make our lives easier. And then maybe if the grade is greater than or equal to 70, we'll say give them a C. And then otherwise, if it's none of that, it must have been smaller than 70, and we'll say it's an F. Of course, you can add B and D as well if you'd like. But that's a good example of a program you might want to make one day. Like Canvas has this program inside of it so that it can show you your grade, right, from your percentage. So let's make this kind of program. Let's ask the user for a score, and then we'll give them back their grade, depending on these criteria. Okay? And so here's the way to do it with just ifs and elses. It's you're going to need nested ifs and elses, and that gets a little ugly. So I'll call this elif.py because this new thing called elif is going to help us here. But here's the setup. We'll be like, let's get a number from the user. We'll be like, input, enter your grade, colon space or something. And then we want to get that from the user. Remember, input gives you a string back, a str. We want to do math stuff with it. We want to compare it to numbers. And so grades can be percentages, which could have decimals. Let's make this a float. Let's convert it to a float. And then we'll save that away in a variable. All right. And then let's do our grade calculation program. All right. If the grade is greater than or equal to 90, it's immediately an A. We can print that out. If grade is greater than or equal to 90.0 or whatever, print A. And now, like if it wasn't true, if that wasn't true, we need an else. But I can't just immediately say it was a C or it was an F, right? We just know it was not greater than 80 or not greater than 90. So it was strictly smaller than 90 if we're in the else. Okay. So it could be either C or F at this point. You see that? I can't just immediately print one thing out. I still need to check, hey, was it a C or F now? Yeah? And so this is where you can put another if inside of your else. So it could be C or F. How do I determine the difference? Well, if it's greater than or equal to 70, it was a C. Otherwise, it was an F. If grade greater than or equal to 70. And so this is inside of the else. Another if inside of the else. Print C. And if that wasn't true, I can have an else as well. Print F. See that? And this will work. This will totally work. But do we see how it looks a little weird? So enter your grade, I don't know, 92. It's an A. If we do that again, enter your grade, 75. It'll be like, all right, it's not greater than 90, so I'm going to do the else. Okay, but grade is greater than or equal to 70, so I'll do this one and not the other. So it's a C. And then finally, if it's none of that, if it's like 65, then we say F because it's not greater than 90, greater than or equal to 90, so it hits the else. And then we try this guy. And it's not greater than or equal to 70, so we skip this if, and we go straight to the else, so we print F. So do we see how this is going to do the right thing? Are there any questions about this version of the program? There's an easier way. And by the way, this kind of checking worked like this. It was like, hey, was it greater than or equal to 90? If that was true, it was an A. This is our program in graph 4. Otherwise, if that was false, we still need to check. It's either a C or an F at this point. If it's greater than or equal to 70. If that's true, it was a C. Otherwise, it was an F. All right, so that's the program that we just wrote. There is a better way, though. If we use this new concept called elif, it makes it so that you don't need to nest the if-elses. You don't need to put if-elses inside of if-elses. You can just put it all in one place, which is a bit nicer most of the time. All right, so let me teach you the if-elif-else statement. All right, and I'm I wish it didn't underline that. It looks like I can't get rid of the red, sorry. So elif stands for else if. It's like a combination of the two. It's like else if together. I want you to read it whenever I write it, elif. I want you to read it as otherwise, because that's essentially what it means. And so here's the beauty of an if-elif statement. It works like this. You again start off with a if. Like you have, if this condition 1 is true, do something. Give like a body 1. Indented, of course. And then, in between that and like an else at the bottom, you can put as many elifs as you would like. An elif, I want you to read it as otherwise, and it also takes another condition. Cond 2, for example. Body 2. And you can put as many elifs as you need. Dot, 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 dot. A bunch of elifs. Like, you can get down to the bottom like elif, and you give some other condition, like cond, this is condition number k, and you give body number k, blah, blah, blah. And then when you're tired and you don't have any conditions to check after that, you can say else. Else colon, as usual. If none of that is true, do this last body. Body k plus 1, I guess. All right? So here's how elif works. Here's how this big statement works. If, elif, 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 all day long until an else. It will check this first condition. And if that's true, it will run this first body, and then it's done with the whole thing. What if, elif, else does is it finds the first condition that's true, runs its body, and calls it a day. All right? So, for example, this elif cond 2, this will only ever get checked. Cond 2 will only ever get checked or tried if cond 1 fails. Only. So it's always just one. Just one of these bodies is ever going to run. It's the one that has the first condition that's true. Or the else if none of them work. Only ever tried if cond 1 fails. That's key. And then it'll, all right, if that's not true, try the next. If that's not true, try the next. If that's not true, try cond k. If that one's true, do body k, then we're done. Only do the first one that's true. Skip out on the rest. And then finally, if they're all false, if every condition is false, do the else statement. So this is only run, this last body in the else, is only run if every single one, every cond is false. All right? So I think that me translating this grade calculation program will help. But are there any questions about this syntax? Some other languages, they make you spell out else if, but in Python it's just elif. And I want you to read it as otherwise. If the condition 1 is true, do body 1. Otherwise, if condition 2 is true, do body 2. Otherwise, if condition k is true, do body k. Otherwise, k plus 1 it is. That's the goal. And so here's how you can transform this program into what I think is a cleaner looking version. So alternatively, it'll do the same thing. Alternatively, using if, elif, else. Oops. So I'll take this and watch. So see how like else and if are next to each other? I'm going to bring them close. I'm just going to delete until it's elif. And then I can unindent all of this. Oh gosh, not that way. Wrong direction. And then I can bring the else out as well. Doesn't need to be indented anymore. That is the same as the above, but I think it's a bit cleaner. It's like, all right, if the grade is greater than or equal to 90, it's an A. Otherwise, if it's greater than or equal to 70, it's a C. Otherwise, it's an F. Only ever one of these bodies will run. It's just the first one that has its condition true. All right, so let's try it all over again. There it goes. 95, A. So they both print A. They both work. They're equivalent. 77, C. They both say C. And then 66. They both say it. So they both work in the exact same way, and I definitely prefer the second version. Any questions about that? That's elif. So yeah, makes your program look a little bit cleaner, but that's how you can chain a bunch of conditions and just do the first one that works. So you do have to worry about the order, though. Let's see here. I think that's all that I wanted to say there. Okay. Let's go to Turtleland some more now. I want to teach you how to use color in your programs, which will make your everything looks super cool. And I'll also show you how to make, like, I think filled shapes. Yeah. So let's go there. So we can go to the documentation page if you would like to look, but I'll show you everything that is important. So Python turtle. We're going to be looking at the pen color function first. So you can color control. You can control the pen color and the fill color. I'm going to show you both of those today. But if you say turtle.pen color and then give it a color as a string, like red or yellow or something, it will set the color to that. Like set the color to brown, and then every future line until you say otherwise will be colored brown. And so that's the goal. So if you say turtle.pen color red, that like changes the paint that is on the turtle's tail. Right? So here's the turtle and his tail, and I don't know. If you say turtle.pen color red, now he's walking around with red ink on his tail. Something like that. Okay? And if you ask him to move, he'll draw a red line. And if you say turtle.pen color blue, and now tell him to do other things, he'll start drawing from there with blue lines. That's how you do it. And so you can have like every new line a different color as long as you change the pen color first. Won't that be cool? So yeah, let me just show you that briefly. It's turtle.pen color. So I'll just make a new program, and I'll call it colored lines.py. And obviously I need to import the turtle library so I can use turtle stuff. I want to make the turtle look like a turtle always. That's just important to me, but you don't have to include this if you don't want to. And then it's all about the pen color. Turtle.pen color. Give it a string that is a color that you want. And remember that strings don't have to be double quotes. It can be single quotes. Python doesn't care. And now if you ask the turtle to move, like turtle.forward 100 or something, he will draw a red line. There he goes. And you can kind of see that the outline of the turtle represents the current color of the lines that he will draw, which is useful as you're debugging. So there was a red line. And now I'll make a blue line. Turtle turn left or something. Turn left 90 degrees, so like act like you're drawing a square. And then let's change the pen color to blue. Just give the string blue all lowercase, and then ask him to go forward by 100 units again. So if I run this, the first line was red, and then when I said change the color, anything after that, any movement after that draws with the blue line. Does that make enough sense? That's a new function in the turtle library. That will make it cool to do things. All right, let's keep on trucking if we're happy. Let's make things even fancier. Let me show you how to fill in your lines that you make. Because you've been making squares, we've been making triangles. Wouldn't it be nice to not just have a blue square outline, but like a blue square filled in? That's the goal. And so there's a concept of fill color. That was next to pen color. If you say turtle.fill color and then give a color, that will set the fill color of the shapes that you're about to make. But you also have to remind the turtle and tell him, hey, I'm about to make a shape. Once I fill it in, or once I finish it off, please fill it in. All right? So that is something you have to remind the turtle library. So the turtle doesn't know when you should start filling in the stuff, so you got to tell him. You have to say begin fill and end fill. All right? You say turtle.begin fill to say, hey, turtle, I'm about to draw a shape that I want you to fill in once I close it off. And so that you say before you start your thing that you want filled in, and then you draw it. You draw your square, your triangle, or whatever. You've like completed all the lines they touch now. And then you say turtle.end fill. And that reminds the turtle to say, all right, everything that I just drew, please fill it in. I'm done now. You're ready to go and fill it in. Okay, so you got to wrap these around, and that will let you draw very cool things. As long as you move the turtle in the right way, you can draw a filled in squiggle if you would like. Just wrap it around, begin fill and end fill. All right, in between every shape. So you draw the shapes in between calls to begin fill and end fill. All right, so let me show you that. I will steal a little bit of this program. File. And I'll call this filled shapes.py. So here's what I'll do. I'll say turtle.fillColor. Give it a color like green. And then I would like to make a shape, right? Let's say, gosh, how do I want to do this? Let's forget about fill color for a second. Let's do, I don't know, let's actually keep most of all this. Let's draw a square, and then I'll show you what to do. Let's turn left 90. So this is going to be a weird looking square, right? Because it's got red and blue. I guess after the last one, we don't need to turn left anymore. But here's like a square. Yeah, it looks kind of cool. And now let's have it filled in with green or some other color. All right, so the way you do that is you say turtle.fillColor, give it a color. By default, it's black. And then you have to remind the turtle, in between you making the thing that you want filled in, you have to say, hey, please start filling in, please. Start filling, please. And you say turtle.beginFill. That marks your drawing to be filled in once you say end fill, right? So that's where you start filling in, Mr. Turtle. And then once you close off your drawing at the end, you say stop filling. And that's end fill. So you wrap your drawings around a begin fill call and an end fill call. And then once you say end fill, the turtle will fill in whatever you just drew. Watch. There he goes. And you can see that his body's color changes depending on your fill color. So by default, it was black. And then, yeah, once he completed it and we said end fill, he filled in his square with green. Are there any questions about that? So just got to remember to wrap your calls around begin fill and end fill. Are you good with that? That is very powerful. It makes some very cool things, I think. Let's see here. Yeah, so I think the next thing that I would like to show you is going to help make your programs look very cool and different every time, especially when combined with the turtle library. I want to teach you the random library in Python. It will, I used some randomness in Scratch before, right? But this will help us make random things. And there's a whole library for it. So let's go there, Python random. And probably the one that we care about most right now is going to be randint. If you say random.randint and you give two numbers, it will give you back a random number between those two, like between 1 and 100, for example. You say randint 1, 100. So it'll look like this. Be like random.randint, like 1 and 10, and then set that result equal to something, and that just saved away in a variable called n some random number between 1 and 10. And of course, you can change these bounds. You got to say import random, though, to access it, just like you say import turtle. It's the name of the library. And so let me show that to you just briefly. Let's make a new program. I'll call it, remember to never name your programs the same name as the library that you're going to use in them, because it'll mess things up. So I can't call this random.py, because importing checks for a file called random.py, and it will mess it up. So I'll call this randomness.py. Import random. And I'll say what I just said, n equals random.randint between 1 and 10. And so that gives back a random number between 1 and 10. It's different every time if I print it. So I'll run it. This time it was 3. If I rerun it, now it was 5. It's a random number. Changes every time. Yeah, now it's 8. It's kind of cool how it was increasing. Okay, now it's back down to 2. So that will help you make a game, for example, that is like interesting. Like the enemies move in a weird way every time because it's random. So that I think we understand the importance of. And now let's use it. Let me show you how cool randomness can be combined with the turtle library. And I think that's the last thing that I want to show you. So, okay. Let us make squares of random size and random location. That'll be cool. right? So first of all, how do we make squares? We have to like go to the starting point, and then maybe we say go forward, go left, go forward, go left, go forward, go left, go forward. So it's always like you start in the bottom left of your square. That's how you build our squares, I think. And so you need to know where to start, and then you also need to keep track of like, you need to make sure to go face east at the beginning, and then also you need to like know how wide your square is going to be because you have to go forward by that amount. And so that's actually all you need to know to make a random square. You need to know where it starts. So we'll pick a random starting point and go there, which involves making a random x and y coordinates, like starting x, starting y. We're going to make two random variables that hold random values, like maybe the random starting x is negative 200, the random starting y is positive 100 or something. Doesn't really matter. And then we also need to pick a side length of our random square. So it's supposed to be arbitrary. It could be anything. It should be different every time. So we'll pick a random size for our squares as well. So we like square side length equals a random number between these. And so we'll have a new variable, a third variable, square side length. And that will hold some random number between 50 and 200. Maybe it's like 150. You'll draw a big one. And so the goal is you run this program, and it will pick a random starting and x and y coordinate for the square, maybe this one, and a random side length, maybe 150, and it will just start drawing a square right there. And if we duplicate this code, it'll pick another starting x, starting y, another size, maybe this one's smaller, and it'll draw another one here. It'll pick another random starting x and y, draw them there. So let's make, they might overlap even. It might be tiny. So that's the kind of program I want to write. And it's different every time because it's random. So let's draw 5 random squares in total, and then we'll fill them in. We'll ask the user for a color too. But let me show you the idea. So I have filled shapes already. Let's keep that. Let's kind of take a lot of that, I think. I'll call this random squares.py. See if I can give us room. And so I'll import random. And let's forget about the pen color stuff. I think that's not really important. We're just drawing a square now that's filled green, I guess. And so this is like this was the square filled in part right here. There. I think that these lines right here draw a square that is filled in. Okay, so that is our square drawing code, and I want this to be random now. All right, so what I need to know is I need to know where to start this square. And so I need a random x and a random y, starting x and starting y. So that's the first thing I'll need. So starting x is that one, starting y is this one. So I'll pick some random starting points. Okay. And then I also need to know how wide this square is going to be. Like, it shouldn't be 100 every time. It could be like between 50 and 250 or something. 50 and 200, I guess, is what I picked. And so we need a variable that will hold a random side length for our square. So those 3 variables describe the exact square that I want to build. Does that make sense? So now the goal is move the turtle to that place, to this random x and y coordinate, and start drawing a square of this random side length there. Okay? And that's going to be our goal. So before we start drawing, we have to go to the random starting point with turtle.goto. Starting x, starting y. And so I have no clue what starting x and starting y are. They're random numbers, but they're just variable values. I can use them like this. It'll get filled in with whatever the randomness picked. And that'll look cool. So I want to start here, Mr. Turtle, please. And I believe that is fine. I also want to make sure that we face east. So like turtle dot, was it set heading? Can't Can't quite remember. That's the random library. Set heading or set H. Okay, cool. Set heading 0. That makes them face east. But also remember, because I'm moving the turtle to some random spot, like the turtle starts out at 0, 0. If the square that I want to draw that's random is over here, if I say go to there, he's going to draw a line like that. I want to pick him up so he doesn't draw any lines. So let's pick the square up before we do any of that. Let's pick a random starting point with the pen up and go there. And that was turtle.up. And then we're in the right spot now, so we can say turtle.down. Now we're ready to draw. And I believe this should do it. So let's run this. And that did absolutely nothing but start us in a different spot. Because look at the code that's drawing the square. Like, okay, square's up here now, but it's always size 100, isn't it? It's always size 100 because I'm saying go forward by 100. Now the square's over here. Whee! But again, that size is exactly the same as always because this is what I'm using as the size, right? That's the forward amount is the side length. And so that needs to change to be this random number that I calculated. Whatever it is, this is the side length, square side length, square side length. Now it'll be in a random spot as well a random size. And that'll be cool. So that actually looked like 100, which was, I guess randomness can do that. Whee. It's looking, that one might have been a little bit smaller. Come on, randomness, give me a giant square or a tiny square. That's smaller. Cool. Of course, it'll be different every time. There we go, big square. And so that's the power of randomness. It's going to start in a random spot, and then we go forward, do our fun stuff. Yay. Any questions about any of that? And I think my screen is too small, so let's make it 200. And every time we run this, it'll be different. Now I have a tiny square. Any questions about any of that? So now, let's see, what else do I want to do? Let's change this so that it's never like that again. And let's ask the user which color they want to use, because right now I've just been hard coding it to green. Let's make the color whatever the user wants it to be, like turtle.fill color, whatever the user would like. So let's ask them, hey user, give me a string that represents the color you want to use. Enter the color of the random square I'm about to draw for you. I'll save this away somewhere, color to use. And the color is supposed to be a string, so I don't have to convert anything. I can just be like, hey, turtle, set your fill color to whatever color to use is. That's the thing I got from the user. It is a string. Hopefully they typed it right. So now, before it starts, on the REPL, it's going to be like, hey, enter the color, red this time. And then it sets the fill color to red and draws a random square. Isn't that beautiful? Same with this. If we rerun it, enter the color blue. Sets the fill color to blue. Then it picks random spots and sizes for the square. So that is the start of the program. Are there any questions about what I've written so far? There's a lot going on. But we've extracted into variables everything that describes a square so that we can make those variables random values. All right, so I think the last thing I want to do is show you how to draw 5 squares in random spots. Because what's the code that does that? This is the code right here, right? All of this, that draws a single, all of this, including picking a spot, this draws a single random square in a random spot and location. Like we pick the color at the start and just go off and we draw the square. So if I duplicate this code 5 times, it will draw 5 random squares. Own it. Hey. So let's do that. One, 2, 3, 4, 5. So I've duplicated the code. It's just resetting. It's always finding new values for x and y, right? Because they're random. Just calling all that all over again. Resetting these variables. And then going to those, whatever their values are now. picking random spots, drawing random things. So I duplicated that square drawing code 5 times. It should draw 5 squares of the color of my choosing, red. Whee. And so one was over the other. That's kind of funny. And so you can make some really cool abstract art with the turtle library. I think you can see how interesting this could be. If you wanted to add some triangles and stuff. If you wanted to change the colors of each square too, God, that would be so cool. We'll get there. And the color, I don't know, what have I not done? Like pink or something. Whatever, they're all there. All these colors exist. And so you can have overlap, it's fine, it's just all random. And so this could be your new background or something. You could make this an NFT. So that is, I think, what I wanted to show you. Are there any questions about this program? So ask the user for a color, we save it away, we use it, set the fill color, and then we draw random squares, which consist of picking random x and y coordinates to start, going there, and then drawing a square there of a random side length. And by how far we go forward, that is the side length of our square, so we'll just put it there. Duplicating that 5 times gets us 5 random squares, because when you ask for a random number, it's always going to be different. I guess it's allowed to be the same. It's just random. That's the idea. Any questions about any of that? Definitely study this. It's a good example, I think, of all this stuff we've been learning. All right. If we're happy, the last thing that I want to show you is your next programming assignment, and that will, then we should have some time for you to start on it. So, yeah, this is all about this silly YouTube video that was like a meme a long time ago. I don't know if any of you have seen it. It's a very weird one, but it revolves around the idea that green is not a creative color. So, have we seen that very weird YouTube video before? I've included it here if you would like to watch it. But here's what I want you to write. Here's your programming assignment. This will be due week 12, so you got 2 weeks. But I would like you to draw a bunch of triangles randomly. And I want you to ask the user for a color like I've been doing. Like, you're going to take my program and use a whole lot of it. You're welcome. But I would like you to write a program that uses turtle and random to draw 10 triangles of random size and location. They could be equilateral, whatever. I've shown you how to draw triangles. You can look at that code. So I want to see 10 triangles of random size and location, okay? Very similar to my 5 squares of random size and location, okay? So that's the idea. You must ask the user which color to use as a fill color, like I did. Like, hey, it could be pink. Hey, it could be blue. Blah, blah, blah. Type whatever you want. And then I want you to set the fill color, except if the user asks for green triangles. If the user asks for green, apparently green is not a creative color, so you have to disobey the user if they ever ask for a green triangle. So you're going to add an if statement. That's me forcing you to learn and use ifs, okay? So if the user asks you to use green, disobey them. Make it pink. Make it some other color of your choosing at that point. Otherwise, obey them. Like, make it what they wanted to, unless they say green. Okay, so if they say red, make 10 random triangles that are red. But if they say green, then don't make it green. Change it to a different color. Does that make sense? So you'll reuse a lot of my code. Yeah.
Does it have to change to a random color, or is it changing to like a predetermined?
You can change it to a predetermined color. Yeah, I haven't shown you how to pick a random color yet. That is definitely possible, and I can show you how, but that is not something we'll talk about until later. So you can predefine your random non-green color if you would like. And so I think that's all I want to say. Yeah, just upload a video as usual, explain your code, show me it all pretty, and show me how it disobeys the user. Like, show me a normal case where it's a normal color, and show me the green case where it picks a different one, something like that. I think that is what I'm looking for. Yeah. Any questions about this program? Should be a fun one. You'll get to draw some cool abstract art. So yeah, if there are no other questions, that is all that I have for us. The rest of the time is yours to get started on this.